So here's where we're going to start today. First of all, can anybody tell me the parent function of exponential? That's a good start. Y equals. In an exponential function, where is the variable? In the exponent. That's what makes it an exponential function. We call it y equals b to the x. Okay? Y equals b to the x is what we call this. All right? Now, something that I want you to remember is that when b is greater than 1, when that base is greater than 1, this is called exponential growth. And when b is between 0 and 1, this is called exponential. Absolutely. Good. Exponential decay. Okay? So we're going to start right here. We're going to add stuff on from there. Okay? What if I add an a in the front? What is that a doing to the function? It's multiplying, right? When there's a multiplying, when something is multiplying, when that's going on in the function, what kind of change does that cause to the function? A stretch or a compression, okay? So I'm going to draw a little arrow right here. This is a stretch or compression. Now, is this a inside or outside of the function? It is outside of the function, so more specifically, what kind of stretch or compression? A vertical stretch or compression. What makes it a stretch? If a is greater than 1. What makes it a compression? Less than 1 or greater than 0. It has to be between 0 and 1, right? Because the other thing that you're trying to tell me at the same time that you have forgotten about, that's okay because I'm reminding you, is if a is negative, right? That's what you're trying to tell me? Well, what if a is negative? So if a is less than 1, basically if a is negative, then what's true? It's a reflection over what? X-axis. It's a compression if a is between 0 and 1. Okay, if a is negative, if a is less than 1, it's a reflection over the x-axis. You okay with that? Okay, well, what else could there be? What else are we used to having in a talking about transformation lesson? What other letters are we used to having here? What other kind of changes do we normally have besides a stretch or oh, we have shifts, right? Those are usually our favorite because some of us like to try to remember to forget the F, right? Okay. And what causes a shift? Addition or subtraction, okay? So do you want to talk about the addition or subtraction inside the function first or outside the function first? Inside, okay? So that's going to be here, x minus h. So that is inside the function. And you already told me it's going to be a shift, but since it's inside of the function, what kind of shift is it? Definitely a horizontal shift, right? So if it says something like x minus h, which direction are we shifting? Right. And if it says x plus h, which direction are we shifting? Left. Last but not least, we have plus k. This is outside. It's being added or subtracted, so it is a shift. And since it's outside, it is a vertical shift. That means if it says plus k, we're going to go where? Up. And if it says minus k, we're going to go where? Down. Any questions about that? Now, is any of that new? No, it's not. Not at all. Okay. Now, could we have a multiplier inside? We didn't talk about that, right? Could we have a multiplier on the inside? We could. We don't usually talk about multipliers on the inside because of the fact that usually that letter that we use is b, right? Except we already have a b in this parent function. You know the rules if there's a multiplier on the inside, right? That's just a horizontal stretch or compression. Remember that? Okay. So I don't want to give you homework on that because you already know that. Okay. I want to stretch your brain a little bit. Not a whole lot, just a little bit. What? Yes. Okay. So here's what your homework problems are going to look like. For example, it might give you an equation, y equals 5 times 1/2 x. And it's going to say graph 2 points. Well, don't I have to have 2 points to graph it? Where am I going to get those 2 points? Yeah, I'm going to pull them out of my head, right? I'm going to use this equation that it gives me. I'm going to use my brain, okay? If I were you, or if you were me, what would be the first x value you choose? You would choose 1? I'm okay with that. It's not what I would choose, but we don't have to argue about that. I would choose 0. We'll do 0 in a second, okay? But I also want to show you another one just to check, okay? What about 1? What is 1/2 to the 1 power? 1/2, right? What is 1/2 times 5? 5 over 2, right? 2.5. Now, here's what I need you to be careful of. Did you notice the order that I just did that in? I said, what's 1/2 to the first power? And we said 1/2, and then we multiplied by 5, right? You know what some people try to do? 5 times 1/2 first. Don't do that. That is against order of operations, and the order of operations police will come for you. How do I know that? Because I am a deputy, and I will come for you. Yeah, you better watch out. Now, I said I would choose 0 first. Do you know I would choose 0 first? Because anything to the 0 power is what? 1. What's 1 times 5? That was a lot easier, wasn't it? Okay. But do we ever want to deal with fractions if we have to? No. Is there a way that I could make this not a fraction? Do you remember what it is? How do I make something from the denominator move to the numerator with exponents? Negative exponents, right? Negative. So what if I made this a -1? What's 1/2 to the -1 power? Doesn't that move the 2 to the top and the 1 to the bottom? Isn't that just 2? Well, what's 2 times 5? 10. So that wasn't difficult, was it? And I didn't have to have a fraction. Okay? So if there's a fraction here, maybe try a negative instead. Yes? Any questions? Sometimes it'll say, hey, here is an equation. I want a table. And it'll tell you like that. Well, isn't this easier than this first problem? Because in this first problem, I have to go plot these points, right? In the second problem, I'm just plugging in numbers it already gave me. I didn't have to come up with my own. What is 4 to the -1 power? -1/4.
At this time, please release all concert choir students to the choir room. Thank you.
What about anything to the 0 power? 1. What about 4 to the first power? 4. And what about 4 to the second power? Thank you for not saying 8. You're letting your brain think before your mouth talks. Good job. Okay. And then what about after this if it says, oh, by the way, we want you to plot this? Couldn't you just take 2 points off this list you already have and plot them on the graph? Not difficult, right? Do you see how this stretches our brain a little bit more than just talking about transformations again? But do you see how it doesn't stretch it too much? You good? Any questions? Wow. Any questions? No. Okay, I'm sorry. I hope you're having a better day after this.